In this video, we're going to talk about linear models. Now, as an example, this table lists the profits of General Electric Company, or GE, in billions of dollars over a 5-year period. So, for example, in 2004, GE had $16.6 billion in profits. Okay, and in part A, we're going to let x equals 3 correspond to the year 2003, and we'll plot the points x comma y, where x is the year and y is the profit, and that's exactly what I've done right here. So notice the point 3 comma 15.0 is right here, 4 comma 16.6, and so on. And notice it seems to be trending upward. Okay, so the profit tends to be going upward. In fact, maybe we could find a line that fits this data. Okay, there's not one single line that will go through all the points, but maybe we could find a line that is a reasonably good fit for the data. Okay, and that's what we're going to look at in part B. It says use the data points 3 comma 15.0 and 7 comma 22.2 to find a line that models the data. Okay, so those are actually the first and last points. 3 comma 15.0 is this first point, and 7 comma 22.2 is the last point. Okay, the profit in the year 2007 was 22.2 billion. Okay, now I've drawn in the line that goes through those 2 points. And the question is, what is the equation of that line? Okay, so how do we find the equation of a line that goes through 2 points? Well, first of all, we need to know the slope of the line and 1 point on the line. Once we know those 2 things, we can find the equation of the line. Okay, so what is the slope of the line that goes through the points 315 and 722? Or 722.2. So let's call this first point x sub 1 comma y sub 1, and let's call the second point x sub 2 comma y sub 2. Okay, and then the slope would be y2 minus y1 over x2 minus x1. Okay, so that would be 22.2 minus 15 divided by 7 minus 3. So that would be 7.2 divided by 4, and that is 1.8. Okay, if you use a calculator, you see it's 1.8. Okay, now to find the equation of the line, we'll do y minus y1 equals m times x minus x1, the point slope formula. And what we have is y minus y1. Now y1 was 15. It's equal to m, which is 1.8, times x minus x1, which is 3. Okay, now let's, I'm going to not write the 0.0, but we'll distribute the 1.8. We have 1.8x minus 3 times 1.8, which is 5.4. Now if we add 15 to both sides, what we get is y is equal to 1.8x plus 9.6. Okay, that is the equation of this black line up here that I've drawn, the line that goes through those 2 points. Okay, and that line is a reasonably good fit for the data. It's not an exact fit, but it's a reasonably good fit. Okay, in part C it says use the points 4 comma 16.6 and 6 comma 20.8 to find another line that fits the data. Okay, so we're going to pick 2 other points. Okay, I've labeled the points that we're looking at, and I've drawn in the green line here. I apologize, I can't draw a straight line very well, but the line does go through these 2 data points. And notice it's a little different than the black line, the line that went through the other 2 data points. The question is, what is the equation of that green line? Okay, so let's do the same thing we did up here. We're going to label one of these points x1 comma y1 and the other x2 comma y2. And we'll find the slope between the 2 points by using the slope formula, y2 minus y1 over x2 minus x1. And what we have is 20.8 minus 16.6 over 6 minus 4. So that would be 2 in the denominator. In the numerator we have 4.2. And 4.2 divided by 2 is 2.1. So our slope is 2.1. And we can use one of these points, either one of them. Let's use the first one because we already called it x1, y1. We can use that point in the point slope formula. Okay, y minus y1 equals m times x minus x1. So y minus 16.6 is equal to 2.1 times x minus 4. So y minus 16.6 is equal to 2.1x minus 8.4. And then add 16.6 to both sides. What we end up with is y is equal to 2.1x plus 8.2, I believe. Okay, and so that's our line that fits those two data points. Okay, and the last one says use the model in part B to estimate the profits in 2006. So in part B, we came up with this model, y equals 1.8x plus 9.6, and to estimate the profits in 2006. Now, the actual profits in 2006 were 20.8 billion. But if we were just going based on this black line, okay, is what we found in part B, what would the profits have been? Okay, what just based on this model of the data, you know, assuming a straight line between this first point and the last point, what does the model say? Okay, does it say 20.8 or does it say something different? It looks like there's a little difference between the height of that point and the black line there. So let's find the difference. Okay, our formula is y equals 1.8x plus 9.6. And the year 2006 corresponds to x equals 6. So we're going to plug in 6 for x and see what happens. Okay, now 1.8 times 6 is 10.8. And so y is equal to 20.4. Okay, so $20.4 billion. Okay, based on that that method, based on our model, we would have predicted that we had $20.4 billion profit in 2006. Now the actual profit ended up being 20.8. Okay. So the model of the data doesn't always exactly fit the data, but we hope that it would be a close fit of the data.